This is the Scion speech adapter that I made. It uses the SP0256-AL2 speech chip here. And this works, it works quite well, works sort of like a copy of the original that came out in the 80s. The only real problem with it, apart from the amplifier not working too well, so I can't get the Scion to supply enough power to drive the amplifier properly. You can, it does work, and you can get speech out of the speaker, but it works a lot better on the headphone output. The only problem is getting hold of these chips. So originally I paid quite a lot of money for 2 chips. They were £10 each. I managed to find a supplier, and I made up 2 of these adapters, and then I thought, well, I'll make the other PCBs up. There's nothing much wrong with this version. There's 1 wire I think needed on the back there, and I did that. Then I tried to get more chips, and it turns out that the price went up to £16 each, which is starting to get a bit ridiculous. And then I couldn't actually buy them. The supplier that I was talking to just didn't reply to me anymore, so I have now got 3 boards which don't have any chips, so I've only got 2 of these chips. Now there's a lot of information about the chips. You can get the data sheet. You can also, some people have sampled, I think, the allophones, the sort of sound snippets that enable it to make speech, and I did find some Rp2040 code on the internet, so I thought, well, I'll make one of these. So this is a 28-pin format Rp2040. Well, basically it's just an Rp2040. It's a bit like the Rp2040 stamp or Pico Zeros that you can get, that I've used. Got one here. It's a bit bigger, and it's got the same pin out in the 28 pins as the SP0256. So I put that together, fiddled with the code a bit because it didn't seem to work properly for me, and what I've got now, with a fully populated one with the now mandatory red bodge wire on there, I've got this plugged into another one of the boards, one that didn't have an SP0256 originally, and I've got it powered. This isn't doing anything, this power cable here. I've got it powered directly onto the Rp2040 PCB. This is I'm still working on it, but this is the sort of the test setup. I've got the headphone connected to a powered speaker, which is my preferred way of running these things anyway. I seem to have some problem with something, pin out or power or something, because I have to run it off this at the moment, and it's not got any code to do the emulation of the chip. It's got none of the allophone address writing stuff. There's some pins which tell the chip which allophone to play. At the moment it's just going to play a fixed sample over and over again. So if I power that up, the noise you can hear is from the speaker. That's the power supply going a bit bonkers for some reason, so something's not working properly here. But you can hear hello world. I'll turn that up a bit. And you can hear that it sounds very much like the original chip. And I'm getting a bit fed up with that now. So, as a proof of concept, it does seem to work. I do have some problems. I've got to do quite a bit of work, I think, to get this up and working as a plug-in replacement for this chip. There's a few features that I don't use on this board that I probably won't implement. Things to do with some of the control lines and so on. But my aim is to get this board working as a replacement for the chip, so that I have some more speech adapters. You can see one problem with it. You can see there, it's quite a lot higher than the original chip because it's a sandwich arrangement. You could probably put the board, this is in a socket, because the chips were so expensive I put them in sockets, but you could mount that straight on the board, in which case it would have a sort of similar form factor, I think. If you look at the PCB itself, it's actually it's about the same. In fact, it may be slightly shorter than the original chip. So without a socket, that would probably fit in the original case. I think if you took off the programming pins and just soldered wires on there. This is very much a development board. But yeah, it is, I think. Oh. Yeah, with a bit of buzzing and clicking and whistling, it is actually playing those allophones. So, thank you. I think the output is okay for the headphones, but it doesn't seem to drive the amplifier at the moment. I'm not sure why. That may be something I've done. I'm just basically driving a direct GPIO output into the amplifier, so it should work, but it's in development. So yeah, I'm going to carry on with it because it looks promising. Yeah, sort of hardware emulator of the SP0256. I've updated the code so that it now works on the speech adapter. I'll just turn it on, load it up, and I've got it attached to a speaker. So I've manually tuned the code and sort of made the delays such that this sounds very much like the original chip to my ear anyway. It's just a for loop in there. I've not used interrupts because part of the development I was having problems with the interface to the chip. So it turns out that the ALD line, which is the latch that drives or latches the allophone number or address into the chip, relies on a falling edge. Now that falling edge wasn't just a falling edge and then sometime later when the allophone was halfway through playing or at the end of that it went high again. It turns out that the hardware of the speech adapter is actually generating a 7 microsecond pulse. Now that's quite short, and when I was running my code on core 0 I think there were too many interrupts going on, USB or whatever, for that to work reliably, and so I moved it to core 1 and that now works. That works fine. So it's quite surprising that you can actually capture a 7 microsecond falling edge, or the falling edge of a 7 microsecond pulse using code, which is what this is doing. I'm not using the PIOs here. There's no real need for that because I've got 2 cores and neither of them is really doing a huge amount. So yeah, let's play another menu. Let's go for the prog menu. And another of my favourites.
Divided by 10 equals 0.14285 of 10 14285 of 10.
So the allophones here are just samples, so you could replace those with anything you wanted. You've got a couple of extra address lines on the SP256 as well, which weren't used, not in this version, the AL2 version, and you could, if you wanted to, because you've got an Rp2040, you could have 4 times as many allophones or other sounds, whatever you wanted. The allophones here are actually samples, so you could record voices if you can actually manage to do that. I don't know what it would sound like, I haven't done that, but that option is there. There's a few things I haven't implemented. The only interface option I've got is the ALD low pulse interface, falling edge, which latches the allophone address and plays it. There's another mode where any 0 turning to a 1 on the allophone address lines will cause the allophone to play, and I haven't implemented that, but it would be easy to do because this is an Rp2040. There's also an external ROM option which I haven't implemented because it's a bit redundant, because you've got ROM in the 2040 that you can reprogram anytime you want. So instead of having an external flash chip, you can just have internal flash samples, which is what's here. The flash samples here are actually in the code, but you could load them into part of the flash that isn't used. On this board there's an external flash chip there, I put a 2 megabyte flash chip like the Pico, but you could have a 16 meg and loads of samples if you wanted to. and then you could use the pins to have some other scheme for talking to the device. You could have it on USB as well. This USB does work, or any other arrangement of pins on the GPIOs. If you wanted this to be something other than an SP0256 emulator, you could reassign in code the pin out of the GPIOs and then access it with some other scheme, I2C or a UART or anything like that. But yeah, so original purpose that I wanted it. That's working. So I've now got a PCB that I can put in to these speech boards, and seems to work fine. I've taken the speaker off here because it just doesn't work on these boards. I think it's the power supply of the Scion. But yeah. And if you were wondering whether it works on the LZ, it does. So it's taking account of the larger display and ignoring the time. So seems to have been written for the LZ as well.
First info found CIR copy delete password LANG please. Find save CIR go up your base. Change 01 for say 2 fully coins fully 0. For say 1 change 198 and 2 fully 0 5 0 fully. Type info or copy please flush. Fully 2 fully 5 fully 2 C5 2 0% entirely 1% 1% fully 8%. Fully 2 fully 5 fully 2 C5 2 0% entirely 1% 1% fully 8%. Fully 2 fully 5 fully 2 C5 2 0% entirely 1%